Alright, people. We are finally ready to go. So my plan for today is to go through a single producer consumer problem, and the implementation here, I want to use the atomic library from C++ and learn a little bit more about that. Okay, so first, to kind of get started, I'm going to look into this. So let's just make a directory prod consume and move our ring buffer code to that. Okay. So first things first, I'm going to be using, both of these are fully done, correct? Yeah. However, I want to use the I want to use this file. So let's first go through it. Nope, not that one. This one. Alright. I first just kind of want to go through everything here and just kind of observe. So we have this, which we can take out. We have a vector. We get our base pointer, add size. We use the vector API resize to fit to the actual size in the constructor, which is also our default. Okay, cool. Alright, this looks great. Now what I want to do is make a header file called ring buffer.h, which kind of has all of these in here. So let's first put these all here. Let's do if not defined ring buffer underscore h. Then we will define ring buffer underscore h. And at the end of this, we'll end this logic. Okay. So that's the start. Okay. Now we just kind of import this entire class into our flow for definitions to use elsewhere. My thinking here is that I'll make the actual producer consumer logic in a separate file, and we'll go from there with checking everything. So we have private, we have all those. Okay. 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 So honestly, we should just take this whole thing, put it here, and then we kind of just want to go one by one. And just forward declare each one of these. And we have our destructor for the fun of it. Cool. We have all those defined. Okay. All right. And then We have our constructor here, which we can also get rid of. Cool. All right, and then this all looks good. Okay. So I think that should be all of our functionality. And for now, we can just comment this main out because we're not going to use it. All right, now to the drawing board. So we will have a ring buffer. Oh, let's use the circle so it looks a little nicer. Okay, we will have this. We will have this. And we will have these memory slots based on the buffer size that we're able to fill and read from. And the memory footprint is super small, but we're able to get this kind of infinite logic or emulated logic because of this like circulating nature of the buffer. So what I'm thinking of doing for this single producer, single consumer problem is anytime we interact, let's put a box around this thing. Anytime we interact with this buffer, we'll simply have a lock. Let's draw a lock. It looks so pretty. A little keyhole. We'll have a lock or a mutex for the producer or consumer to read or write to this buffer. So the thought here is our ring buffer is our critical section and interacting with it is our critical section. So what we don't want to do is have both of our threads, producer or consumers, interacting, modifying memory at the same time. This is extremely undefined behavior, so a safe precaution is to add a mutex, which is itself atomic, meaning only one process can interact with it at a given time. So like in the same time slot, both the producer and the consumer cannot unlock this lock, for example. So kind of how this works is it'll start unlocked, and we want one of these to, first of all, let's write down that this is an atomic process. Okay. This will start, so init this equals 1. 1 means it's free, 0 means it's locked. Let me just confirm that. Let me just see. Okay. All right. Yeah, so we'll init this, and then we just need I'm gonna try this thing called a spin lock, which the spin aspect is if the resource is locked down, aka the mutex, we're not able to grab a hold of it with a thread, it'll sit there busily spinning until the mutex is freed. It's not obviously that wastes clock cycles, because it's just sitting there waiting for it. But it's pretty simple, and for the case of just the overall logic that we're trying to understand here, it gets the job done. So yeah, for our mutex, can we use? Oh, we can zoom in. Oh, okay. Let's go here. Whoa. Can I not? Hang on. There we go. Okay. So for our mutex, we have a lock. And we have an unlock. And this is it. Like this is the class. So when we have our spin lock, we'll lock it. I might need to dive into the atomic C++ library just for a second, because the example I'm seeing, a lot of things don't make sense. I'm gonna go to Geeks for Geeks for this really quick. Let's look. The Geeks for Geeks article is terrible. Oh. Okay, so the part that I don't understand in these examples is this std memory order acquire. Sorry, I'm on a browser and I'm trying a different screen recording setup for easier readability. But okay, we kind of know what we want here anyways. So we can add include ring buffer.h, and we will make a new class for mutex.h, and we can copy this to some extent, just to, because a lot of it has the same wording with different actual naming, but this will be a pretty small header. I just want to keep things distinct. We definitely do not need a buffer size. We will have a class called, we'll just call it mutex. We'll call it mutex. What's private here? Let's clear all this first so we can think. These will all be Boolean. Oh. Okay. I think I'll just have this header with everything, but essentially, let's include atomic, just introduced in C++ 11, I believe. Oh, wait, that's what I wanted. Okay. So, our lock flag is set to lock flag init. And what we'll do in our public, what happened there? I'm in insert visual. That was weird. We'll have a void lock function. This will be a while loop. This is the busy part. Lock flag dot, and then let me go to this Geeks for Geeks. Test and set. Test and set memory order acquire from the standard library. Obviously need to touch up on that specific verbiage, but test and set. And what the what test and set does, I can see. I can pull this up really quick. Just really quick. So the test and set gets the value and sets the value of the flag. Clear resets it, and test gets the value. So testing and setting is where we want to read the value and then hold it down if we're setting it. So that's the memory order acquire part, I'm assuming, is we're driving it low. But I guess we can. Standard library, memory order acquire. Memory order acquire. A load operation with this memory order performs an acquire operation on the affected memory location. No reads or writes in the current thread can be reordered before this load. That did not give me much information. Okay. Is a memory ordering constraint, right? Ensure proper synchronization between threads. It applies to load operations. When an atomic load operation is performed with memory order acquire, it guarantees the following. No reorder of subsequent memory operations. All memory operations that follow the acquire with the current thread cannot be reordered. Okay. So that's the atomicity. Release store. So we can. Alright. We know what to do. Let me switch back. Alright. So we want test and set of memory order acquire. Alright. Memory order acquired. Alright. And then this is just a busy loop, so we can simply do that. And then we'll have another with the unlock. And this will just lock flag dot clear std memory order release. Let me confirm something. Is lock initialized to 1 or 0? Okay, and that'll be it. Okay, so this is initialized to false. So the lock, when it's locked down, it's true. But just so we remember, okay, so let me go back here. This is initialized to, that's terrible. 2 0. Okay, that looks like a G. That looks bad. 0. Okay. So we can and kind of zoom out on this for a second. What's the vertical aspect of this? Is this all we have? Oh, all right. So yeah, this is what we're working with. Okay. All right. We have this. So now in a tab new, prod, produce, and consume .cpp, we will first include our mutex.h. We will include our ring buffer.h. We need to include threads, which I believe is just threads or thread. And then we obviously want to print stuff out, so we will also include our input-output stream. Okay, so first things first is we will have a mutex called lock. We will have a we'll have two threads here where that was weird. Okay, we have two threads here that we care about. We have producer, consumer. And for the sake of things, let's just make a main that initializes these. So std thread. P is of producer, and we should probably pass in an array. So, or a vector, that is. So let's also include vector here. Okay. Okay, so we'll have, let's just stick with ints for the sake of easiness. So we have a vector of int, and we'll pass it by reference. Bec. And then we also want to read data into an array, or at least items in an array. So we'll actually do the same thing here, and we'll pass by reference so we can modify it. Okay. Well, hang on. Let me think about this for a second. Because we'll also want to pass in. Do we want to pass it in? Or do we want to make the ring buffer... we probably want to make the ring buffer a... how are we ending? We'll make it a global, because our mutex also a global. For our producer, we are going to write data into ring buffer. And for our consumer, obviously, we are going to read data. So with the ring buffer, we will rb.read. Let's look back at what we're doing here. So we'll just do vec of we'll just always do it for the first. Actually, we should probably keep a counter. static int idx equals 0, idx. Once it's written, we will increment our idx. Okay. That's kind of all we want to do in our consumer thread. And then in our rb.write, we just want to write vec, probably with the same kind of thinking. We just want to do this. We'll pass it in like and of that. Okay. So we have a producer, we have a consumer, so this will be data. std vector int input std vector int output. And I am going to verify that this is kind of where we're at. Oh, and obviously we want to lock. Oh no, we can't name it the same thing. We'll have this as spin lock. We'll do spin lock dot lock, and then we will unlock it after. And we will do the same thing here. Okay. All right. Okay. Let me see where this is at. All right. We're gonna cat this produce consume, and I just want to kind of see where we're at here. What I'm trying to figure out is how I continuously read and write here. Utux. Okay. Just some quick fixes. While IDX is less, okay. Shit, I like that. While, oh, we can't make P IDX. I'm worried these will, no, they won't. They won't. I know they won't. while our IDX is less than vec.size, here's where we want to read everything. Sorry, write everything. All right, we will do that. We will do that. And then we will add that back in. Okay. And then we'll just do the same with our other loop. So while IDX okay, let me think about this one. Oh, yeah. I guess we're just checking if we're filling it up. Why IDX is less than vec.size. We'll lock it. We will read. Can we not do this? I think we can do that. I'm like 80% sure we can do that. We want to check if RB dot is let me look at how I is underscore is full is empty. Okay. We'll lock. Wait. We'll lock out here. Wait. Let's think about this. Why would we lock if the ring buffer's full? Oh, we just pass by it. Okay. I thought we were gonna have some deadlock there for a second based on the flow. But we're chill. We're chill. Let's oh. Okay. And then the last thing we'll do is unlock our locking mechanism, and we are good. And then I'm just going to chat to see what we would do here. So let's first add our references. We will p.join c.join. And then I'm just going to copy this because it's easier that way. Okay. And then we just need to initialize. And what's our ring buffer size? Yeah, why not? We can do that. And then we'll just have output, and we just want to init our size. So input dot size, and only thing that concerns me is the input and output here, but I think we should compile and see where we're at. So G++, we are gonna run this on C++17, produce and consume. Okay. P and C were definitely declared in the scope. Let me see what's going on. Oh, I didn't. Okay. So is empty has that. So that's one right off the bat. Invalid conversion. Value type to int. Okay. Okay, whatever. Are we writing by reference or just... Because if we're not writing by reference, we don't write by reference. We can just do this. Okay. Int star to int, but... So if I really were to do int val, add it here, that val equals the refer... Oh, wait. No. And val. And then our vector of idx equals val. We really have to do that? Why is thread not a member of stdjoin? I mean, I guess we can also try and... Yeah, that's what I thought. We didn't need it. Okay. Thread is not a member of std. This is going to be a sad way to have to pause this if I have to. So chat's pretty much saying I need a new minGW. So G++ -- version. We're here. All right, intermission. I have to fix my installation. I'll be right back. Okay, I fixed it. Alright, I fixed everything. Let's go. So, g++, trash std equals c++ 17, and we just want the producer consume. Okay. Instantiation. Oh, so we do need. Okay. What is std ref? Alright. It's that. Std ref of input. Std ref of output. Okay, what's going on here? Undefined reference to ring buffer. Where do we have unsigned long? Is it the buffer size? Yeah, let me look at something. Cat ring buffer dot h. Oh. I see, so I have to change how the ring buffer. Oh, I have to change all of this. Can I just have all of the logic in the header file? Yeah, that's what I'm gonna do. That's a lot of work. Alright. Let's go to our ring buffer.h. Let's add it down. Actually, let's add it. Let's add it here. Yeah, and we don't need anything from this. That's really funny. Why did it only copy some of this? That was weird. I haven't seen that before. Anywho. Okay. Here we go. Cool. And is it the same every time? Let's add, I want to add something to the produce consume. Oh, we can add it in the in our mutex. We'll just do std cout locked or locking and then we'll do unlocking just for fun. That's really cool. That's really cool. All right. Well, that is a good milestone for me today. I am gonna do some laundry and watch some football. But yeah, this was a good challenge. Definitely learned a little bit about how them mutexes work and the atomic capabilities and APIs in C++. But yeah, all things considered, some pretty big learning milestones, and yeah, I'm a fan. All right, see y'all.